Hi, this is James Gardner, the CineTechGeek, and today we've got a very special video about ultra high performance networks in the digital media workflow. And this is coming on strong. If you look at IBC and even NAB this year, there's a lot of talk about video over IP networks. And today we're going to show you the new ultra high performance equipment. Everyone knows about 10G. Well, 10G is pretty old hat now. We've got 40G and soon to be announced by Mellanox. I'm here with Suda from Mellanox, is 100G. But we'll leave that there for now. We actually want to look at affordable ultra high performance networking. And today Suda's going to show us some of their equipment. It's mainly used in data centers for people doing like Amazon, etc., people like that. But now it is at a price point where we can use it in very typical post-production facilities can afford this equipment. You'd be surprised, and that's why I wanted to make a video with Suda today to show you what you can get, how it works, how you plug it all in together, and how to make it materialize in your infrastructure. So to start off with, right, we've got well, Suda, thank you for coming today.
You're welcome.
We've got the NICs here, or the network interfaces, and there's 3 different types. So Suda, can you just go over them very quickly? What's the difference?
Yeah, sure. So I guess a bit of background to Mellanox. Fortunately, we're completely end-to-end, so we can demonstrate everything from the adapters, the switches, and the cables, and right down to the silicon as well. So what we have today is over here the 10G NICs, which obviously is quite common nowadays in data centers, but trying to bring that into the SME sort of market. Then we have the 40G NICs, which really are quite important for the virtualization market, for storage and high performance computing. And then over here is the new 100G NIC. Everything is dual port. You can either get it a single or dual port. And so yeah, we really are moving along to the next generation now.
Yes, we are. Now, just quickly, we want to go over quickly how this stuff all plugs together and you can put it into your infrastructure. Now, over here, first of all, right, this is their switch. Now, the switch is basically in here. We've got 12 40 gig.
Correct.
Right. Now, the interesting part about these 40 gig interfaces is that they are actually 4 10 gig interfaces all rolled into one, aren't they?
Yeah, so basically our 40G ports, or this QSFP standard, allows for 4 lanes, and every lane has 10G basically. So there are a couple of ways for you to utilize a 40G switch as a 10G switch, or even a 1G switch. So what you would do is, firstly, you've got this breakout cable here. So this is a copper cable, very low cost, around $180, that plugs into the switch port at one end at QSFP, and outcome for SFP plus 10G.
10G, that's right. Okay. So that gives you the ability to break this 12 port out, so you could go 12 times 4 one 10G interfaces. So you can really see how this is really well designed for machine rooms and computer rooms. Now the other interesting portions of these is that, firstly, you got, just quickly so people understand, these are pretty much you can get these transceivers.
Yep.
Now these transceivers come in many shapes and sizes. You've got these transceivers. This converts from the QSFP.
Yep.
Down to just FSP. Q means quad. So
yeah.
So 4 of these, like there's 4 cables on here, go. So the quad FSP goes to just a QFSP here. So
SFP plus there.
FSP plus there. So and you can get all these converters. So you can really convert a QFSP to any sort of format you want, be it fiber, be it a copper. Typical Cat6A sort of implementation, you can do all that sort of too. So if you do need to branch out to other equipment for different purposes, you can. Now, there's also on the aspect of this is that these are all well and good, but the QFSP transceivers can be quite expensive, and the cabling that's involved between these devices is quite a limiting factor, and that's probably the most complicated and confusing part of this solution. So I can show you all this equipment, but this isn't Cat 5. You just don't plug it all in. You need certain cables for certain sort of reasons, and you can see these quad cables and fiber optic cables. And this is where we want to quickly in this video go over like some simple examples of how you would do it in a digital media company if you're a small post-production company and you just want to get this going quickly and take advantage of these super high performance or ultra high performance networks. So just quickly, we've got the copper cables that we showed here, and we've got some more over there, etc. We've got copper and fiber, and the most cheapest way, for example, if you had one of these switches and you had a traditional production house where you actually had the editing systems in the computer room, which is a more of an old school because the machines used to be so big and heavy and loud. You used to put them in the machine room and run video and keyboard cables to a editing suite. In today's age, the systems are much quieter and you tend to put them in the room. So how far can we run these cables and how much do they cost? This is one of the big problems with this. So I'll let Sudha go on with that. So what sort of distances can we go on the copper and the fiber, and how much do they cost?
So the question of copper versus fiber really comes down to distance and speed. So for 10G, Mellanox has copper cables from 1 meter to 7 meters. Everything has transceivers attached.
So they're basically like this. The cables are built like this, so they're not really well suited for pulling through walls or anything.
Correct. So basically, they're for situations where either within the rack or between multiple racks inside a data center. And at 10G, these cables are $20. At 40G, these cables are about $50 for a 3 meter cable. So it's a very cost-effective way to build high-performance networks within the data center.
That's right.
Then, like you mentioned, what happens when you have to go between rooms or go longer haul? Firstly, sort of between rooms or even up to 200 meters, we have cables that are 15 meters, 20 meters, 50, 100, 200 at 10G and at 40G.
So that would be like these cables.
Correct. So a 20 meter cable at 40G, based on fiber, with modules attached, so you don't have to buy any other modules, will be $250.
Okay, cool.
So
because that's pretty amazing, because if you have a look on eBay, you just buy a module, that can cost you that much alone just to buy a module from a third-party manufacturer. So that's a very good bundled solution from you guys.
Yes, I mean it really changes the way you think about do I use the existing infrastructure that's already there, or and limit sort of the performance, or jump to the next generation of technologies. You can either run single mode fiber, in which case you can plug in different modules in the future. You can plug in a 100G module in the future, and that gets you future proofed.
So that you're talking about where you buy these modules individually.
Yep.
And you just plug in the type of fiber you need for that.
Correct. So you can buy very cheap single mode or multi-mode fiber and have that as your as something that doesn't change between technologies.
Yep.
And so the trend we see in data centers especially is single mode. That single mode can carry the 10G or the 40G or the 100G with the same fiber.
Okay.
But in more the small to medium, you can consider our cables that are already pre-terminated, and a very cost-effective way of having fiber at longer reach.
Okay, so let's just look at that. If I was going to say, man, this looks fantastic. I'm a small production house. I've got a file server in the other room, and I've got 2 editing suites. And wouldn't it be amazing if I could just run 40G down to those stations from the file server? So I imagine we need to buy one of these, right? So how much would one of these cards cost?
So a single port 40G card is around $400. A dual port, $500.
These are US prices? So $500 for a dual port card?
Yep.
Okay, so I could buy three cards, one for the server, 2 for each of the workstations.
Yep.
And then I'm up for basically buying some of these pre-made cables. They're very cost effective.
Yep.
And you said before it was
$250.
$250 for how long?
20 meters.
For 20 meters, which would typically be as much as you want. So we're talking about, to 40Gify your infrastructure, you're talking, way under, under $1,500 to get the 40G infrastructure into your post-production facility. That's pretty amazing, and you wonder why you'd bother even going to 10G when you can actually jump up to these sort of speeds. So if we were then going to the next step, is that we need to buy one of these, a switch to put in the middle if we want to go to more than that many locations.
Yep.
So what sort of price are we looking for this one?
So this is a 12-port 40G switch, and
is this the entry-level switch?
It is, and it can be thought of as a 48-port 10G switch as well.
Yeah.
And this is a $6,000 switch.
Okay, so $6,000.
So even if you wanted to use it as kind of a fan out, which means you have one in your data center, one close to your desktops, and then from each one you can have copper. So you can have fiber between the two sites, and then multiple coppers within each site.
Yes.
That's another way to do that.
Okay, now the other thing is that, and hopefully you'll change this in the future, is that we need to visit this, is that 10G is still pretty fast as well, and 10G can go over Cat 6.
Yep.
And a lot of facilities already have Cat 6 installed, and recabling a facility isn't always an option, because that can cost a large amount depending on how, if the walls are all set and all, etc. So one would say that I'd want to jump also to a typical Cat 6 infrastructure too. What's your suggestion for that at this moment, considering what the products you have? How would you do that?
So basically, there are solutions. So the basic reason all our investments are in S&P Plus, just for the background, is it's better in latency and lower cost, lower power, and which matters in the data center sense when you have thousands of servers. Every watt counts.
Right.
But in the small to medium businesses where there's already existing infrastructure, I guess one solution is to have a switch that has both the S&P Plus and the base T standards, perhaps a low-cost switch that can basically do the translation for you.
Yeah.
So
basically you go from one of these ports into a low-cost 10 gig switch, would hopefully have an uplink port, which is at a 40G type or QSFP.
Most likely it'll be 10 and 10, so you may not get to the 40 to 40 end-to-end in that scenario.
Could you I imagine you could team or bond, so you could get it might only have two. You could use two and get 20 to the other switch, and then 10 out of those ports. That's very doable.
Correct. Yes. So you can bond a number of 10G ports to achieve the aggregated bandwidth you need for the type of data that you're trying to move around.
Yeah, okay.
And we also have on the network card side, there are some other companies using our silicon to make 10G base T adapters as well.
Right.
So you can still get the latency benefits of Mellanox inside, and but it's manufactured by third parties, and that's basically the two ways of doing it, I think.
Now one thing I wanted to talk about, and a reason, like you were talking about latency before, and you really, for digital media workflows, latency is actually quite an important factor as well. For example, if you are using this to if you had an editing workstation and it was getting its media from some sort of file server over this high-speed Ethernet infrastructure, the latency will actually have an effect on how fast the data comes down, and the feel and the speed of the editing system. So it actually is an important factor that 10 gigabit copper or Cat 6 based networks are very cost effective and easy to get going, especially if you've got pre-laid cables, etc. But if we're talking about optimum performance with these new network infrastructures, as you can see, the latency matters. So take that into consideration. It's another reason why, Mellanox, as you can see, his main focus is on performance and being the best of performance can be for those very highly demanding Amazon Web Server type sensors, or what's the Linux space. You were saying a lot of your vendors are building high uptime equipment, etc., based on open.
Yeah, so virtualization or storage that needs high availability. So there's always two things there. There's the raw latency.
Yes.
So latency as low as possible, everything from the silicon processing it switch to switch ports, right up to the adapters and the cables, all having low latency. But then also not dropping packets, because that really affects latency, and so that's one thing Mellanox is known for, is zero jitter, because we never drop a packet. It means that with some other vendors, if you load up the switch with more than 4-6 ports and try to achieve full line rate, that's when the silicon can't handle all the packets.
From my understanding though, I've read that, like, you've got the 12 ports here, you can pretty much go 100% on every port, and it still won't drop a packet, and you've still got plenty of bandwidth.
So we can go 36 ports at 56G and still not drop a packet.
Wow, that's amazing. You can see why, even in the high end, where they're doing completely changing SDI switches, those big multi-port switches, to having these sort of things, because the reliability is there. Because a lot of people were talking is that, we'll never go away from copper infrastructure because, you know, we could drop a packet. Well, yes and no, it's sort of been fixed. This equipment is now that fast and that reliable that that's not really a concern now. It's really what we're waiting for is, there are standards at SMPTE. There's a standard called SMPTE 2022, which initially implemented doing 3G SDI over Ethernet, right? So what does that mean? So you would have seen, or IBC, for example, this year you had Sony talking about a complete change of infrastructure. They had a whole OB truck that run on IP.
The second pillar of Sony's focus is IP. Everything connected with IP. Behind me you see our brand new processor, switcher and server, all running IP in a 4K ecosystem. Building on our commitment to open standards, we are also working in collaboration with 36 partners of bringing the network media interface to market, enabling you true 4K, high frame rate and high dynamic range, all on IP.
Blackmagic, very well known for bringing amazing devices in at incredible price points, also demonstrated their new mini converters, which would convert from SDI to SD 2022 3G SDI over Ethernet.
What we're showing at IBC is a technology demonstration of Ultra HD connected via a 10G optical IP switch between two prototype Terranex Mini IP video products. We're currently talking to major broadcasters about workflows, and if you're looking at IP-based systems, please come by and we can discuss your needs.
So that is significant. So why this is such an important factor to small independent post-production houses is that it really changes the need for your infrastructure. In the next year, it's very conceivable, for example, to say that you move all your data over your networks. It's mainly in file formats like EXR or DPX files. So these super fast, ultra fast networks, the faster you can go, the better, right? But also you need to look at these pictures. You need to put them on grade 1 monitors or projectors. How do you get to these projectors and monitors? Well, that's when you all of a sudden have to also implement in your facility coaxial infrastructure for sending SDI over coax around. Well, once we have a device, a converter which goes from network to SDI, well, that need has disappeared. You only have the one infrastructure, and that's all Cat6 or fiber. If you want to send an image to a screen, you type in the IP address of the mini converter, and bang, it's on that screen, because that screen is on the network like every other computer or device in your facility. That is a massive change in the way we build our infrastructure, and it is things like these interfaces. The big difference between why these are so important is because with high dynamic range, 4K material at 60 frames a second, 10G just doesn't cut it if you want to send that to a screen. But with 40G, it's all there. We can do all the current and future standards with these NICs right now. So this is why you really, if you're going to jump, you need to jump over 10 to a degree, because we are heading to high dynamic range very quickly, and you will need 40G to do those sort of interfaces and those sort of displays. So Mellanox is answering that need, and I met them at SMPTE Australia this year, and when they told me some of the prices for this stuff, I had to do a video about it. I had to get Suda up here to explain some of these things, to explain how easy it is to get this stuff going and how inexpensive it is. Now, this is one video that we've done. I'm actually going to talk to other people from Mellanox, because this is only really half the story. Having the physical infrastructure, then actually being able to utilize it to the capabilities such as 40G are very different stories. Even just to get 10G to work properly, usually a lot of tweaking may need to be done with your servers and your clients. But 40G is a completely different story again. And I know, for example, through talking through Sudo, and I'll let you talk about this quickly, is that you've got this RDMA capabilities in the cards. And talk about that for a second. How does that improve everything?
Yeah, like you said, firstly, there's no point having 10 or 40G if you can't achieve line rate.
That's right.
And often TCP is what's holding you back. And TCP uses the CPU of your computer to do a lot of that network transfer, which means it's taking away CPU cycles from your rendering and things like that as well.
It also means it has to travel over the bus into the CPU and out again, which is takes a long time.
Correct. So basically built into any of our network cards, from the lowest end 10G to the highest end 100G, is a technology called RDMA. So what that means is we can write from one server to another server's memory directly without using the CPU, and we offload all that network traffic and work to the NIC. So, and not only that, we cut through TCP altogether. So what that means is for clients, for typical protocols like iSCSI, we do it over RDMA, and it's called ISER, I-S-E-R. So iSCSI over RDMA. These are all things that are already built into Linux for a long time. It's just a matter of, as soon as you plug our network cards in at both ends of a cable and load the right drivers, you're suddenly going to achieve line rate in your data transfers. Probably the slowest bottleneck then will become the storage itself and being able to push out that much data.
That's right.
Another typical one is Windows SMB Direct 3.0. Which is built into Windows.
So Windows Server, for example.
Yep, that's right. It's built into Windows. If you have a Windows SMB client and a server, and our NICs, whether it's 10G or 40G, it'll also detect that and cut through over RDMA. So maybe pull out 6 gigabytes a second of storage rather than what you're sort of traditionally used to, which affects responsiveness, affects number of your productivity. And so those are sort of, I guess, higher level or more advanced things that you can discuss in sort of
we'll try and do that in another video, because it's actually a very complicated and super geeky thing to talk about. Over, like, everyone knows NFS and Samba, but when we get into these high performance line rate NICs, etc., it's like a different level. So that's something. It's amazing to see how Mellanox has actually come to the ball and work with these vendors like the Linux and Windows to actually try and make a lot of that issue transparent and just for it to work. So that's an amazing thing to see. I'm hoping to play with that and try and test it out myself down the track at some stage. I'm going to try and buy some of my own NICs and do some of my own experimenting when I have some time. But that's very interesting. But the one thing that's missing from our conversation at the moment is media. As a media professional, you're probably very Mac centric. So can you speak to capability or what's happening with the Mac side of the equation? Like, I'll be the first one to say, I love my Macs and Mac operating system. I'm more of a Linux guy, but Mac, unfortunately, in the high end, I know a lot of people who are actually moving away from Mac because you can't get this sort of infrastructure to work on Macintoshes. Right. So is there any future where it will work on Macintoshes?
So basically, our NICs don't have Mac drivers. That doesn't stop you from using the switch capabilities and the cables right now. But in terms of actual Mac drivers, that's still something that we're developing and hope to have that out at some point.
Well, that would be really good. If it does, I'll be one of the first people to put it up and to shout to the lamps, because this is a big change in our industry and how we work. So I think we've really covered everything. Is there anything else you want to mention?
No, that's about it.
Anyway, thank you very much,
Cool.
Suda.
Thank you.
Very
Cheers.
interesting.
Appreciate it.
Looking forward to it and to playing with this equipment, and hopefully my viewers out there who are interested in the bleeding edge and really getting into high dynamic range and these other formats which really need these sort of throughputs have had some good discovery with my video today and thrust forward into the new realm of high dynamic range, because it does look amazing. If you've seen what I've seen, it's going to be big. Anyway, bye for now from James Gardner at CineTechGeek and Suda from Mellanox.
Thank you.